when current divides into two parallel paths, there is a rule called current divider rule, uh, which actually says how the currents will be divided. It comes from the fact that the voltage, because these are two parallel branches, the voltages will be the same. So basically, if the voltage is V, that will be I1 R1 or I2 R2. So what I will do, I will show the current divider rule. What happens, the current I1, that is actually full current divided by R1 plus R2, that is the two resistances, times the other resistance. And that actually happens because of the parallel resistance. From the parallel resistance formula, we can actually show that. So V is equal to I1 R1, and if the total current I, that is actually of R1 R2 times R1 plus R2, so that times I is the V, and also I2 R2 or I1 R1 is also V, because these are all parallel, this one. So if we replace this one with one resistance, that will be the resistance through which the I goes, the full I, and that full I times this equivalent is the V. Also, if we split them into the into the given resistances, or the two resistances, then that will be I2 and R2. So now we can see, if we use this one, I1 is R1 R2 over R2 plus R1 divided by this R1, and then I is there, so R1, sorry, so R1 is gone. So that's why here we have R2 in the formula, like that. Similarly, if we took this one, we can see that the R2 would be gone, and we would have the other resistance, which is R1. So we can use this to find current through respective current in two parallel resistances, through two parallel resistances. So I will do a problem, an example, so that here this is a circuit, and we need to find V1, which is this voltage across this resistor, and V2, which is voltage across this resistor. So first, if we see, there are parallel branches, so these two, 3 plus 1, that's 4 here, and these two together, if I try to find what is the current here and here, so these two are parallel, 5 and 20, these two are parallel. So the equivalent parallel is 5 times 20 is 100 divided by 20 plus 5 is 25, so that's 4 ohms there, and this is also 4 ohms, so the same resistance. So what will happen, current will just become half. If it was not they were not the same, then we needed to use this formula, and we would get the current. So if this is I1, but in this case, since they are the same, so 4 plus 4, and then that's 8, and then multiplied by 4 here, so it's just half. So basically the current here in this direction is 15 milliamps, 15 amps, sorry, and in this direction also is 15 amps. So the voltage V1 will be 15 times 3, so that's 45 volts. That's done. Now we have to find this parallel current. This current 15 ohms is also will go through this one and this one. So we have to find what is the current in each of the branches. So this is I here, which is 15 amps, and this one is 5 ohms, this is 20 ohms. So we need to find the current through this one, or we could actually since we need only the voltage here, not the current, actually we are interested only in V2, So we could have actually found the equivalent resistance, which we already have found, 4 ohms. So 15 times 4 is 60 volts. So that would already give us V2. That's fine. So we actually don't need to, but let's find the current through each of the branches. So what would happen is, if we want to find this current, let's call this I20. That would become 5 plus 20, and the total current is 15. So this is total current, these are the two resistances, times the other resistance, which is 5 here. So that would be 15 times 5, which is 75, and this would be 20 plus 5, which is 25. So that would be 3 amps. So now we can see the current through this resistance is 3 amps, and that also is giving us 20 times 3 is 60 volts. So we get the same voltage. And of course this current will be, we don't need to use the formula actually, because if this current is, total current is 15 and this is 3, this has to be 12 ohms. 15 minus 3, 12 amperes, sorry. So 15 minus 3 is 12 amps, and 12 amps times 5 ohms is also, so 12 amps times 5 ohms is also 60 volts. So they should be the same, and that's what we are getting. So yeah.